Now we'll move on to problem 18. So in this case, we are talking about non-conducting sheets with a uniform surface charge. So we have two non-conducting sheet with the surface charge of the sigma 1 and the sigma 2. Remember that in the case of a non-conducting surface charge density, we have to remember a very important rule, which is given by the electric field, is no longer dependent on position, but it is given by is proportional to sigma over 2 epsilon. So remember there's factor of 2 here. So remember that in the case of a conductor, there's only one component, so that the 2 factor becomes 1. But anyhow, let's change the color. Okay, so fundamental formula is that electric field is given by this one. Okay, sigma over 2 epsilon naught. Sigma is charge over area. So that basically is Q over length square. So that it is similar to the point charge. Okay. The point direction is point perpendicular away from the sheet if the charge is positive, and toward the sheet if the charge is negative. Okay, that's the fundamental formula we have to remember. And then we need to think about the case. Remember that this is the sigma 1 is positive and sigma 2 is also positive. Okay. So that the field from the sheet 1, E1, is points away from it, so that it is toward this positive x directions. And field from the sheet 2 is also positive, such that it is in these directions. But what is important thing here is that electric field between these. So for the what we have to do is that sigma 1 is point away from it, so that in the case of A position here, so we need to find out what are the positions in the things. What is the electric field between the sheets? That's the case. So here, so we are talking about sigma 2, 1. I think that I made a mistake here, but anyway. So let's assume that this is the sigma 1 and sigma 2. Then what is happening here is if I'm here, I would feel that it is electric field is in these directions. Okay. And sigma 2 will give you these directions. So key point is that if it is in the between the two plates, they have opposite directions. So that's the key things. So as it says, it's one is right and the other one is left. Okay. And calculate the individual magnitude from the formula sigma O2 epsilon naught. So you get this one and this one, and then you get one of them should be opposite direction, so that it should be minus. Okay, and then you get this one. So in this problem, it is important to note that first figure out for this formula, and then figure out the directions directions of uh, the electric field. So in fact, so in, you have a two direction of the electric field from this charge distributions. So if you are in this between these two plates, then one of them is going to be right hand toward the right, and the other one is toward the left, so that they are in opposite sign in terms of direction. That is the key thing. And then let's try to think about this case. So now it is a dipole. It's a kind of a dipole. So it is composed of a Q1 A and Q1 B, and they are plus minus 2.5 microcoulomb. And find the magnitude of the force at the Q2 charge exerted on the dipoles. Charge is giving a force to this dipole. And then easiest way is that find out the force on this one and force on this one from the Q2, and then you can find out the net force. So we have the charges are given, and separation is given, so it forms a P is QD. So you know what the dipole moment is. And then there is external charge Q2, and it says that 1.7 centimeters from each Q1, so that the distance between them is A, which is 1.7 centimeters. Same as this. And in order to find out the force, you have to go back to Coulomb's formula, and then it says that we have to specify the relevant charges Q1 and Q2, and then its distance R square. In this case, R square is only equal to A. Okay. And the vector sum is that you have to do the vector sum. So F2 force between the charge Q and the Q1A, and force and between the charge Q1B and the charge 2 should be vector summed. That's the routine. And we have to think about the directions. Angle between the altitude of the triangle and the side A can be found using the half base, such that and we need to find out this angle. Okay. This angle is important to find out the components, the horizontal component. So think about. So force would be between these two would be, and then you have to do you have to decompose into vertical and horizontal component, and then you will find out you need a certain angle, zeta, and then this zeta can be found out like this. So we have A theta, and given by this one. And cosine theta is given. And then you note that Q2 attracts the positive Q1 and repels the negative Q1. And depends on the sign, you have both attractive and the repulsive forces. And the horizontal component and the vertical component should be calculated separately and then add them together. So net force is given by this one. Note that what is happening here is that you have a Q, there's a Q3. And then you should note that Q3 is Q2 is negative, right? Q2 is negative. Q2. So Q1. Right. So this is Q1B and the Q. And then this is negative, so that it should be attractive force coming this way. And this is the repulsive. Okay. So if you think about horizontal component, you have this right-hand directions, but in this case, it is left-hand directions. So that vertical, the horizontal force would be cancelled out, and only the vertical will survive. And then vertical component can be found out this one, and then you can get this one. Okay. So in this case, what is important in solving problem is you need to know the basic formula, the Coulomb's law, and then you need to understand it is the vector sum. So that depending upon the charge, you could have attractive or repulsive. And then by vector sum, you need to do the component by component. So that means you need to think about what are the x component, what are the y component, and then you can get the answer correctly. So once again, in this same situation, but in this case, we need to find out the torque exerted on the dipole by Q. So we need to understand some system parameters. Dipole consists of the two charges and separated by distance, this d. And the third charge is in price of 1.8 centimeters from both. And then we need to understand the situation. So we need to have a formula go back. We know that tau is P cross E. And then obviously the dipole will interact with the electric field. And then this, if you look at it, is an electric field. And if there's a dipole will fill at this position, electric field at this position. So then in other words, probably this is the place where the dipole will feel the electric field from Q2. So we need to understand the positions. So distance to the center on mid is given by d of 2. Okay, so here's the d over 2. And then distance between here to here is given by this triangular formula. Okay, note that. D over 2. This is A. This is what? And this is H. So what we now know is that we have a dipole here and the distance between the dipole and the charge. Distance between the dipole center and the charge. And then what we can do is that we calculate the electric field at the dipole center, E, and then this electric field will interact with the P such a way that it will generate the P cross E. So that's the logic you need to understand. So when we mean by the field, it is a function of a space. So you need to know what locations we are talking about. So in this case, location is the center of the dipole. So what we have to think about is that we have to think about Coulomb's law to find out two charges as well as the torque is given by this one. And then we can do both ways. We can think about dipole and then try to find out the electric field and then the field and the dipole interactions. But also we can try to find out individual forces acting on the A and B. And then we can calculate the F from the Coulomb's law. And then we can get the R cross F. And then from this one, we can get the angle between them is important. So note that Q2, Q1, so that we have a certain force, okay? And then what we have to do is that, so let's take that this is the position. And then the angle between this position vector and this is important. This is nothing but important for this is angle theta, what we have calculated, or phi, and then is angle is defined in this way. Remember that H, A, okay. So that's the reason why we calculated H, right? And then torque is given by R cross F. R cross F is in this case, distance is d over 2. So this is the origin, and this is the distance, and this is the force. So R cross F should be based upon these parameters. So d over 2 comes in, which is corresponding to this one, and then phi comes in, the angle between, and then you get this one. So in other words, this charge will try to give a force here and then give force there, and then try to rotate. Okay, and that's the torque. And torque is given by QE. Okay. And now we have situations Q1 and Q2, and then the question is the electric field at the point P here. What are the electric field? So in order to find out electric field, you need to find out the electric field component from the charge Q1 and distance 1, L1, and charge Q2, L2, and then try to find out the vector sum. Vector sum is important. In this case, in one-dimensional case, so in one-dimensional vector is either right or left hand. So R1 is given, R2 is given, okay. And then electric field is given by charge divided by the R square. And then direction is depending upon the sign of the charges. The field points toward the negative charge and away from the positive charge. That is important case. That will determine whether it is moving right or left. And then field due to the Q1, Q1 has a negative charge. So Q1. So that means anything is going to this direction. Okay. Negative direction. And if you just plug in the numbers, you will get this one. Field due to the Q2, and it is positive. And it is repulsive, so that it is also to the left. Okay, so that even though Q1 and Q2 has a opposite sign, their electric field at the point P is in the same direction. Okay, and then you get summation, and then you will get the answers. Okay, so here's the minus sign is the toward the left-hand side. Okay, that's it for the chapter 5, and I hope you understand how these problems are solved. You need to understand basic formula, but what is important is that you need to understand the geometry and the position and what are the requirements. That is very important. In some case of equilibrium, you need to figure out all the forces. In some problems, we have to come up with a free body diagram where the tensions and gravitational force and electric forces are identified. And then from this, we can come up with an equilibrium condition where the net force is 0. Okay, good luck with your exam preparations. Thank you.